Welcome to Quality Branding Hub. The channel is for the quality control engineers, site engineer, civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also I am going to discuss about a very important topics of the concrete. Rather, why we are using fly ash in the concrete. Nowadays, fly ash are widely used in the concrete. But what is the reason behind that? Why you are using fly ash in the concrete? Today's video I will discuss each and everything on that matter. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. So without wasting time, let's jump into the subject, that is why we are use fly ash in the concrete. Now in today's world, any projects whatever we are doing, that is with the help of the concrete. Without the concrete it is nearly impossible to do the projects. But in the concrete there are different material, that is a sand, there is a coarse aggregate, that's cement. But the cement has a heat of hydration and other properties. So mitigate that one, we are introducing the fly ash into the concrete mix. But why fly ash or why not other product? So there is some criteria or there is some benefits to use the fly ash in the concrete. So what is that benefit we have? Now for that also we need to know, before that why we are using fly ash in the concrete, we need to know the about the cement or the concrete. What is the concrete property? So the concrete is the combination of coarse aggregate, fine aggregate and cement with the water. So what is happening when we are adding water into the mix? It start reacting and making a hardened paste. That's called the hydration of cement. So in short, in heat of hydration, what the hydration of cement, that we want to know, because it is the process that makes the cement bed or the hardened paste in addition to the water into the cement. So that is why we need to know what is the hydration of cement. In short, it is the procedure. The heat of hydration is the heat energy released when water reacts with cement during the hydration process. So here it is a catch, that it is making a hardened paste but it is releasing the heat energy as a production. But why? Because it's the exothermic reaction. So this heat is coming from the process of the hydration, and this heat is not good for the concrete because it is can causes the cracks, in thermal cracks in the concrete. So these reactions occur when cement particles come to contact with water, leading to the formation of chemical compounds that contribute to the setting and hardening of the concrete. So in short, whenever we are adding water into the mix or into the cement, it start reacting and they make a hardened paste. But during this process, due to it is an exothermic reaction, heat produces, and this heat can be causes of the thermal cracking. So these are the hydration of cement, and in this process we are getting our concrete harden or the concrete strength. Now before going to that why we are using the cement, that we want to know that what is the main component of cement. So whenever we are adding water into the mix, it start reacting with the cement. But cement is a composite material. Again, there are different particles or different chemicals is present inside the mix. So what that one, there are mainly 4 component of the cement, that is tricalcium silicate, we are called it C3S, or the dicalcium silicate, we called it C2S, tricalcium aluminate C3A, and tricalcium aluminiferrite or C4AF. So these 4 compound in together they are making cement, and whenever we are adding water into the mix, this all compound is start reacting with the water and they produce a hardened paste that we call the concrete. But also they are producing heat energy and other chemicals. Now we'll come to that part, that what is making whenever we are adding water into the mix. That means what the chemical reaction is takes place or chemical reaction is happening inside the mix whenever we are adding water into the mix or the concrete. First, what is there? You see there are 4 components, that is tricalcium silicate, dicalcium silicate, tricalcium aluminate, C3A or C4AF. Now, first stage of reaction that is happening with the C3S, not the C2S or the A or C4A. Whenever we are adding water, the first component, that is tricalcium aluminate, that start reacting with the water. So what is happening? The reaction, it's with the water, it's making a gel, that is the CSH gel we called, and this CSH gel is the hardened paste that gives the strength of the concrete. So tricalcium silicate plus water, that making calcium silicate gel or the calcium hydroxide. So calcium silicate hydrate or the calcium silicate gel, it is beneficial for our concrete because this given the strength. And C3H is start reacting immediately whenever we are adding water. This generates the early strength, that is in between 3 to 7 days. Whatever the strength we are getting is mainly from the reaction with the C3S and the water, and they are forming C3S CSH gel. Now just look from here, whenever this gel is forming, that is CSH gel, which gives the strength, but also it is producing the calcium hydroxide, CaOH. Now this calcium hydroxide, whenever they are dilute with the water, they make the concrete porous. And if the concrete become porous, what will happen with the porous areas? The other chemicals like chloride, sulfate, carbon dioxide, that will increase inside the concrete, and with the help of the water, that is happen chlorination of concrete will happen, that the steel rebar will corrode. If the sulfate is allied is coming, this ettringite will form, and again it will deteriorate the concrete. And if it is the carbon dioxide also increase inside the water, the carbonation will happen. All the cases, either steel or the concrete will deteriorate. So this 3 molecule of calcium hydroxide, whatever it is producing in the reaction with the C3S and the water, this is harmful for the concrete. So here we are getting early strength with the reaction of C3S and C2S, but in the same time calcium hydroxide also, which is not good for the concrete. The next stage of reaction, that is take place with the dicalcium silicate, that is C2S. First it is reacting with that C3S, that the tricalcium silicate, then it is reacting with the dicalcium silicate. Now what is dicalcium silicate, how it is reacting? It is also reacting with the water, and again it is forming the gel, that is CSH gel. Again it is producing the calcium hydroxide. This C2S is giving the slowly with the that contributes the strength in 28 days or the beyond. So first stage of reaction will take place with the C3S, and then second phase of reaction will take place with the C2S. C3S will give the early strength and C2S will give the long term strength. But with this, whenever they are reacting with the water, they are producing calcium hydroxide as a byproduct, and this calcium hydroxide is harmful for the concrete because it makes the concrete porous whenever they are dilute with the water. Now we need to reduce this calcium hydroxide, otherwise the calcium hydroxide will make concrete porous, and also then it is the heat of hydration also more, so it can be possible that thermal cracks can generate. So with the cement, whenever it is reacting, we are getting the strength, we are getting the concrete product, but the same times concrete become porous and concrete become maybe thermal cracks can generate. So these two are become the problem. Now the scientists are starting how these two can be minimized, these two effects can be minimized in the concrete, so that we can get the right concrete product and right concrete, and there will be no thermal crack, and then porosity can be minimized. And the next stage of reaction is formation of ettringite, that primary reaction of C3A, that is C3A reacts rapidly with water and sulfate ions from gypsum to form a ettringite, that is at phase. This prevents C3A from reacting too quickly, which could cause for flash setting reaction is C3A CS4, and again this equivalent C3, this calcium ettringite, tricalcium aluminate gypsum plus water, it's from the ettringite. Importance of ettringite formation: control setting time, prevents false setting. So it is controlling the setting time also, and it is help to reduce the false setting from the concrete. If the false setting is happening, the concrete will not generate the strength which we are designed for. So the C3A also help us to make our concrete as per our requirement. Now this is the third phase, and the fourth phase is it is reacting with the, let me delete it, reacting with the C3 ettringite by tricalcium aluminate plus water, then monosulfate. This conversion of ettringites into monosulfate delays C3A reaction. So here ettringite is formed. So then again this it is react with the C3, and after gypsum is consumed, excess Ca3 is react with ettringite to form monosulfate, a stable phase. So here it is ettringite plus tricalcium aluminate and water and monosulfate. This monosulfate is stable under normal condition, and but delayed ettringite formation can occur in hot environment, causing expansion and cracks. So it is depend on the environment, it can happen. But again this ettringite is monosulfate is producing, this is stable one. So these are the four stage of reaction: first C3S, then C2S, then C3A. Now another part is that C4AA. What it is reacting? It is reacting C4AA plus gypsum plus water, and they makes the calcium ferrite hydrate spread ettringite. So what is it again? Ettringite is forming, so it is also giving the stable form. So these are the main reaction with the cement whenever it is adding into the water in the 4 phase, that is rather it's a 5 phase. First with the tricalcium silicate, then it's a dicalcium silicate, then it's a tricalcium aluminate and reverse ettringite, then again with the tetracalcium alumina ferrate. But when whatever the strength we are getting from C3S and C2S. Now here we are already discussed that whenever it is producing the concrete, they produce the calcium hydroxide, which is not affected and which is not good for the concrete. It makes the concrete porous. Now scientists has come to know that which product can be used so that this calcium hydroxide can be reversed, or it can be effect of the calcium hydroxide can be minimized. Now here it's coming to the effect of the fly ash. The fly ash, what is happening whenever we are adding water? Fly ash is a fine powderly product. So what is fly ash? That we want to know, because this fly ash has a very good properties, and it helps to concrete to prevent the porous, because it's react with the calcium hydroxide. So fly ash is a fine powdery material that is a byproduct of burning pulverized coal in thermal power plant. It consists primarily of silica, alumina and iron oxide. So what is this? Is the byproduct where we are getting from the coal thermal power plant when it is burning the coals to produce the electricity. Now it is a byproduct, and if we are not using the byproduct, what will happen? It will dispose to the environment, and it will eventually pollute the air, water and the land. So if we are using fly ash into our concrete, it helps us to give the sustainability, or it helps us the environmental protection. So this is the fly ash. But if you want to know about the fly ash, I have made a detailed video, link is there or in the description. Please check, you will get the full information. Now we need to know that what is happening when we are adding fly ash into the mix. That means there is a certain percentage we can use into the mix, and that has the given guidelines in IS 456 and also IS 10262, that what percentage of fly ash we can use in the maximum. So what is happened, how fly ash influence cement hydration? Now reacts with CH, the pozzolanic reaction. CH produced from C3H and C2S reaction is consumed by fly ash. So what is happening? See, here we are getting C3 is calcium hydroxide, here is also calcium hydroxide. In C3S 3 molecule, here is 1 molecule. So if 3 is more, the early strength will get, but the same time more calcium hydroxide will produce in compared to the calcium C2S. So if we are using the early strength gain concrete cement, that means more calcium hydroxide will produce. Now we need to remove this calcium hydroxide from the mix in order to make the concrete stable, or the porosity will be reduced. So how it can react? See, SiO2 from the fly ash. So it's coming from the fly ash and it is reacting with the calcium hydroxide with the water. Again, it is forming the CSH gel. What is the CSH gel? That is the main ingredient or the main product that give the concrete strength. Now from the cement, what is happening? We are getting the strength, but we are getting the calcium hydroxide that is also given the make the concrete porous. Now whenever we are adding fly ash into the mix, that makes it react with this and they making CH gel. So what is happening? We are getting more strength. And what is this calcium hydroxide, what is coming? That is also not present in the concrete, so it is not dilute the concrete, or it is not making the concrete porous. So in this way, fly ash is mainly helping us. And also whenever we are making the fly ash, or we are using the fly ash, what is happening? The heat of hydration production become less, so there will be less chances of the thermal cracking. So it is, please note that the calcium CaOH, that whatever is coming calcium silicate and calcium hydroxide we are producing, this calcium hydroxide is harmful for the concrete. It makes the concrete porous. So whenever we are adding fly ash into the mix, the SiO2 or from the fly ash, it's again reacting with the calcium hydroxide and it is making the CSH gel, so it gives the strength. So what is our harmful product? We are using that one, also making our concrete more stronger. So these help us to form the concrete. So that is why it is very much important to use fly ash into the concrete mix. Again, it is delays initial hydration or the slower strength gain. So fly ash all slows the hydration of C3S and C2S, leading to a slower but more refined strength gain, and also the heat of hydration or the generation of heat is become less, and beneficial for the mass concrete, reducing the heat of hydration, and reduces sulfate expansions, control ettringite formation. See, in our products we are saying that there are ettringite we are forming. So if the ettringite is more, then it can the sulfate expansion. So it helps to control or reduce the sulfate expansion, that's control ettringite formation. So in this way it also helps. And then also it's improved the workability. Why? The spherical particles of fly ash act as a tiny ball bearings, improving concrete flow and reducing water demand. So if it is reducing the water demand, that means water cement ratio is become less and we are getting the smooth strength. And then it is reducing cement consumption. So why it is whenever it is reducing the cement consumption? Because we are replacing the part of the cement with the fly ash, so it is reducing the total consumption of cement. In this way it's help us to reduce the CO2 emission from the cement production. All we know that whenever we are producing the cement in the plant, it's emit the carbon dioxide, which is the harmful gas or the greenhouse gas which is affecting our environment. So whenever we are using the fly ash, the other way we are making our environmental sustainability. And also fly ash is a byproduct that I already discussed, that is cheaper than the cement, reducing the overall cost of the cement. So these are the reason we are using the fly ash into the concrete. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me, but I'm waiting for your valuable comments, so that from your valuable comment everybody will be benefited. And thank you once again for watching me.